Today we are going to see about classification of elements. Introduction. The arranging of elements into different groups on the basis of the similarities in their properties is called classification of elements. In the year 1800, only 30 elements were known. Now at present there are 114 elements known. So it becomes difficult for the scientists to remember all the properties of elements. Therefore, there was a need to classify elements. Next, early concept of classification of elements. First, Dobereiner's traits. In 1870, John Dobereiner, a German chemist, suggested a method of grouping elements based on their relative atomic masses. He arranged the elements into groups containing three elements each. He called these groups as traits. Dobereiner showed that when the three elements in a trade are arranged in the ascending order of their atomic masses. The atomic mass of the middle element is nearly the same as average of atomic masses of other two elements. This statement is called the Dobereiner's law of traits. Limitations. Dobereiner could identify only three traits from the elements known at their time, and all elements could not be classified in the form of traits. Newland's law of octaves. In 1866, John Newland arranged 56 known elements in increasing order of their atomic mass. He observed that every eighth element had properties similar to those of the first element, like the eighth note in octave of music is similar to the first. The arrangement was known as law of octaves. The octave of Indian music system is Sarigama Padanisa. The first and last notes of this octave are same. If the example Sa, likewise in the Newland's table of octaves, the element H, thus they have similar properties. Limitations. There are instances of two elements being fitted into the same slot. Example, cobalt and nickel. The law of octaves was not valid for elements that had atomic masses higher than that of calcium. Newland's table was restricted to only 56 elements and did not leave any room for new elements. This is the Newland's octaves table. Next, Mendeleev's periodic table. In 1869, Russian chemist Dmitry Mendeleev observed that the elements of similar properties repeat at regular intervals when the elements are arranged in the order of their atomic masses. Based on this, he proposed the law of periodicity, which state that the physical and chemical properties of the elements are the periodic functions of their atomic masses. He arranged 56 elements known at that time according to his law of periodicity. This was best known as the short form of periodic table. Features of Mendeleev's periodic table. It has 8 vertical columns called groups and 7 horizontal rows called period. Each group has 2 subgroups A and B. All the elements appearing in a group were found to have similar properties. All the elements appearing in a group were found to have similar properties. For the first time, elements were comprehensively classified in such a way that elements of similar properties were placed in the same group. It has noticed that certain elements could not be placed in their proper groups in their manner. The reason for this was wrongly determined atomic masses. Limitation. Elements with large difference in properties were included in the same group. Example, hot metals like copper and silver were included along with soft like sodium and potassium. This is the periodic table of the elements. Next, modern periodic table. In 1913, the English physicist Henry Moseley, through his X-ray diffraction experiments, proved that the properties of elements depend on the atomic number and not on the atomic mass. Consequently, the modern periodic table was prepared by arranging elements in the increasing order of their atomic number. This modern periodic table is the extension of the original Mendeleev's periodic table and known as the long form of periodic table. Modern periodic law. Atomic number of an element indicates the number of protons, positive charge, or the number of electrons, negative charge. The physical and chemical properties of elements depend not only on the number of protons but also on the number of electrons and their arrangement, electronic configuration in atoms. Hence, the modern periodic law can be started as follows. The chemical and physical properties of the elements are the periodic functions of their atomic numbers. Based on the modern periodic law, the modern periodic table is derived. Features of modern periodic law. All the elements are arranged in the increasing order of their atomic number. Next, the horizontal rows are called periods, or 7 periods in the periodic table. The elements are placed in periods based on the number of shells in their atoms. Vertical columns in the periodic table starting from the top to bottom are called groups. There are 18 groups in the periodic table. This is the modern periodic table. Classifications of elements into blocks. The elements of periodic table are classified into 4 blocks, namely S, P, D and F block. S block elements. Alkaline earth metals are called S block elements because lost electron in their electronic configuration occupies the S orbital of their valence shells. S blocks comprises 14 elements, namely hydrogen, lithium, helium, sodium, beryllium, potassium, magnesium, rubidium, calcium, cesium, strontium, francium, barium and radium. P block elements. These elements are in group 13 to 18 in the periodic table. They include boron, carbon, nitrogen, oxygen, fluorine families in addition to noble gases. They are also called as representative elements. The P block is home to the biggest variety of elements and is the only block that contains all 3 types of elements: metals, non-metals and metalloids. D block elements. It includes group 3 to group 12 elements. They are found in the center of the periodic table. Their properties are intermediate to that of S block and P block elements, and so they are called transition elements. F block elements. It includes 14 elements after lanthanum, 57 called lanthanides, and 14 elements after actinum, 89 called actinides. Advantages of the modern periodic table. The table is based on a more fundamental property, the example atomic number. It correlated the position of the element with its electronic configuration more clearly. The completion of each period is more logical in a period. As the atomic number increases, the energy shells are gradually filled up until an inert gas configuration is reached. It is easy to remember and reproduce. Each group is an independent group and the idea of subgroups has been discarded. Justification has been offered for placing lanthanides and actinides at the bottom of the periodic table. Based on uses. Metals are typically hard, shiny, malleable, fusible and ductile with good electrical and thermal conductivity. Non-metals. A non-metal is an important that does not have the characters like hardness, shiny, malleable, suitable and ductile. Metalloids. Elements which have the properties of both metals and non-metals are called as metalloids. Example, boron, arsenic. Conclusion. The periodic table is important as it's organized to provide a great deal of information about the elements and how they related to one another. The periodic table might be used to predict the properties of elements, even those that have not yet been discovered. Thank you.